Good afternoon, class 11. So let's continue. Last class we spoke about the features of S and P block elements. So today we'll be doing D block elements. So what are they? They are the elements where the electron enters into D subshell of the penultimate shell. D subshell of the penultimate shell. Now what is penultimate shell? Penultimate shell is your second last shell. It is one shell before the valence shell. Okay, it's the second last shell. Okay. So let's speak about the properties. First property is your electronic configuration. Their electronic configuration, the general one, is n-1, d 1 to 10 and ns2. Sorry, ns 0 to 2. Okay. Second one, here the elements have high melting and boiling points. High melting and boiling points. Then third, they form complex compounds. And most of the compounds here are colored. Most of them are colored. Example, we have copper salts as colored, we have copper sulfate colored, then we have nickel salts as colored. Okay, the next property is most of them can be used as catalyst. Okay, used as catalyst. Then they are paramagnetic. Paramagnetic means what? They are attracted towards magnet. Okay. The last point under this will be they show variable valency. Okay, so these are the common properties of D block elements. Now we shift to the F block elements. What are they? F block elements where the electron enters into F subshell of the anti-penultimate shell. Anti-penultimate shell means the third last shell. So let's look into the properties. First one, their general electronic configuration is given as n-2 F 1 to 14, n-1 D either 0 to 1 or n-1 D 0 to 2, and ns2 is common. So these two are common, that is F and S are common. Now this D can vary, either it can be 0 to 1 or it can be 0 to 2. Now when it's 0 to 1, then we term it as lanthanides. They are lanthanides. And when it is 0 to 2, they are basically actinides. They are actinides, okay? Second property, they are heavy metals. Heavy metals with high melting and boiling points. They are radioactive by nature. Actinides. Actinides are radioactive. Then they form complex compounds as well. Okay, and they show variable valency. What are the common features of your F block elements? Now, how to understand the group number from the configuration. Like period number we can easily understand. Basically it represents the number of the shells or the higher quantum number, higher principal quantum number. Now group number, how to understand? Group number for S block, the group number is equal to number of electrons in S subshell. S subshell. For P block, it is equals to 10 plus number of electron in S and P subshell. For D block, it is number of electron in D and S subshell. Okay, and for F block, we have only one group number, that is group 3. So that's it, class 11. Thank you.